Some people say that investing is not about hitting the jackpot and striking it rich. Rather, it is a lifelong journey of investments that grow over time, thanks to the magic of compounding. In this video, we're going to look at the math behind this magical compound interest. Let's take a moment to review exponential growth. Let's say your wealth advisor recommends buying Tesla stock because she thinks the share price will increase by 12% per year. If she's right, how much will a $5,000 investment be worth in 20 years? For a problem like this, we can take the principal, that would be the $5,000, and we're going to multiply that by 1 plus the interest rate as a decimal, so that'll be 0.12, raised to the power of the number of years. That would be 5,000. 1 plus 0.12 raised to the power of 20. This 1 here is important because that allows us to keep what we started with and then add 12% more in this case. And to the nearest dollar, that would be 48,231. So we started with $5,000 and ended up with $48,231 after our investment grew 12% per year. Next, we're going to look at compound interest, and that's where we're getting paid more than once per year. Now, when we're working out problems involving compound interest, we use a very similar formula to the one we just used, but we end up dividing the annual interest rate. Remember, the interest rates we're told in the question are always annual interest rates. And sometimes we'll have to adjust that. So here Lila invests $12,000 into an investment which earns 11% per year. So notice that's an annual interest rate. In 5 years, how much will Lila's investment be worth if interest is compounded semi-annually? That means she gets paid twice per year. So instead of getting paid once per year, she gets paid twice per year. That's semi-annually. So what we're going to do in our formula is we're going to adjust this interest rate so that it's the interest rate for half of a year. And then we also have to adjust the number of payments we get, because it's not going to, if she doesn't get 5 payments, she's going to get 10 payments, since she gets paid twice per year. So we'll start with that $12,000. And we'll multiply by 1 plus the interest rate as a decimal, divided by 2, because the 11% is an annual interest rate, but now she's getting paid twice per year. And then raised to the power of 5 times 2, because now she's going to get 10 payments, because since she gets paid twice per year. All right, just to see how this works out, let's get this piece by piece here. So instead of 1.11, we have 1.055 because we divided 0.11 by 2. And then instead of raising it to the 5th power, raise it to the 10th power because we're going to get 10 payments. So now I think this would be a good time to work it out in one shot on our calculator. We'll round to the nearest dollar, so we're going to round that 7 up to an 8, since the number after it is 5 or bigger. So after 5 years, her $12,000 investment grew to $20,498. Now Rory invests $7,000 into an ETF, which earns 8% per year. In 20 years, how much will Rory's investment be worth if interest is compounded quarterly or 4 times per year? All right, so we'll take that $7,000 and multiply by 1 plus the annual interest rate as a decimal, 0.08, divided by 4, because we want this will be the quarterly interest rate. And all that raised to, not to the 20th power, but to the 20 times 4 power. Because he'll be getting paid 80 times over those 20 years, since he gets 4 payments per year. 0.08 divided by 4 equals 0.02. And work out 20 times 4. So every quarter, he's multiplying the amount of money he has by 1.02. And we get $34,128. So Rory's investment turned his $7,000 into $34,128. Now Vince has his $2,000 in a savings account, earning 4% per year. And in 25 years, we're wondering how much Vince's investment will be worth if the interest is compounded monthly. That just means he gets paid 12 times per year. So we'll need to divide this 4% by 12 to get the monthly interest rate, and then multiply the number of years by 12 to figure out how many payments he's getting. So here we're dividing the interest rate, and then we're multiplying the number of payments. So we're dividing by 12 and multiplying by 12. We have a repeating decimal, so I think to minimize the rounding error that we're going to get, I think we'll just do this all in one shot on the calculator instead of rounding this decimal, because that will affect our answer. Right, so I have 2,000 multiplied by 1 plus 0.04 divided by 12. I'm going to move outside of the parentheses, and we're going to raise that to the power of 25 times 12. So that's our exponent there, the 25 times 12. Let's see, into the nearest dollar, the number after the 7 is a 5, so we're going to round that 7 up to an 8. So that's $5,428. All right, so in his savings account, his $2,000 grew to $5,428. Now, Natalie, she has her money in a savings account, but she's only earning 1% per year. That's a pretty modest interest rate, so her money's probably not going to grow that much. However, we're wondering in 20 years, how much will Natalie's investment be worth if interest is compounded continuously? So instead of compounding monthly or daily or weekly, it's just constantly compounding. Now we have a special formula for that. And it's an interesting formula because it has this number E. Now if we go to our calculator and type E, we notice that E is equal to about 2.7. So, but then it keeps going. So E is actually an irrational number. The decimal never stops or repeats. So it's a little bit like the number pi. It's such a special number, we gave it its own letter. It's the number E. And as you continue your math studies, you'll find this letter E showing up in interesting places. So in this formula, we'll try to use the E button on our calculators so that we get all those decimal places in there. All right, let's go ahead and just churn through this formula here. So we take the money that we start with, the $3,500, and we're going to multiply by this number e, raised to the power of the interest rate as a decimal, so that'd be 0.01, times t, which is 20 years. All right, and since e has a whole bunch of decimal places, I think it'd be best if we just type this all in to our calculator in one shot, just to minimize any rounding errors we have. So we have 3,500 times e. Now in this calculator, I find that over here in function. And here it has e to the x power, so I'm going to go ahead and use that. And for the exponent, it was 0.01 times 20. I do this all in one shot on the calculator. I need to make sure that the 0.01 times 20, that whole thing is in the exponent. All right, into the nearest dollar, that'd be 4,275. All right, so over 20 years, her $3,500 grew a little bit. She was only getting 1% interest per year. Okay, I hope these examples about compound interest have been helpful. This is Mr. Ela, signing off.